everyone. I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. Problems on application of Laplace transform. This is the topic today we are going to discuss. First, what are the formulas related to Laplace and inverse Laplace transform? We will have a discussion while solving the problem itself. And what are the steps to be followed for finding this application of Laplace transform? And we are going to take a problem to solve this application of Laplace transform, how it works. This is the problem we have taken. We have to solve. There is y double dash plus 7y dash plus 10y equal to 4 e power minus 3t. Y of 0 equal to 0. The meaning is at the point when x equal to 0, the value of y is 0. At the point x equal to 0, the first derivative of y, the value is minus 1. So to solve this, what are the steps actually to be followed? Before going to this, while solving this differential equations, both Laplace and inverse Laplace, both will play a role. Regarding Laplace, we will take the derivative formula we will be taking to solve this. That is, the step 1, we will apply this equation given, the differential equation. Laplace, we will apply both the sides. Laplace transform. Then after applying, we are noticing it is y double dash. The derivative, the formula L of f double dash, it's nothing but s square L of y minus, f is there, so we will be writing f. Yes, f of 0 minus f dash of 0. So the s, if you are taking, it is going on decreasing. If it is 2 derivative, we will stop the formula up to first derivative. That is, here n, we will stop the formula up to n minus 1. So with the help of this formula, we will substitute in the particular places. Then the next step, we will take these values also will be substituted in this particular place. Then we will be getting a simple equation we will be getting in terms of L of f. There we will apply inverse Laplace transform rules. So inverse Laplace transform using to solve that, we can take elementary functions help. So elementary functions in the sense L inverse of 1 by s minus a is there, e power at, we will be writing. Similarly, L inverse of a by s square minus a square if it comes, the final stage, then we will write cos, numerator a is there, sin hat. Like that, simple elementary functions are there. The formulas which is available, we will use it. If not, any form it will come. First shifting theorem, that is the final stage. If it is in this format, that is f bar of s minus a format, it is there, then we will write e power at into f of t. So this way also we can move. This is not possible. We will move to second shifting. Second shifting, the final stage, if f bar of s is multiplied by e power minus as, then the solving we will be getting f of t. The t is replaced by t minus a into h of t minus a. So depends upon the problem. When we are applying the inverse, these are the formulas to be tried. So this is also, suppose if it becomes failure, then we will move to change of scale property. The change of scale property, that is, if the particular s, if it is divided by a, then the final f of t, the t is replaced by t by a into 1 by a. If it is also not suitable to our given problem inverse finding, then we will move to the next one. So the next one is multiply and divide by s. So the multiply and divide by s. So if f bar of s is multiplied by s, anyway that we will be getting solving f of t. For that we have to find first derivative. To do that, before that, the eligibility rule, f of 0 equal to 0. This condition is satisfied only we have to touch this one. So this is regarding multiply by s. Suppose in case our inverse divided by s if it comes, then we will extract f of t. This t is replaced by u, and we will do the integration with respect to u and range from 0 to t. In case this is also not suitable to our problem, our given problem, next step, how to move. So we can say it derivatives and integrals. So now this is the derivative. N times the differentiation has been done. That is minus 1 power n. The t power is n and f of t. Fine. Integral, that is the f bar of s, the integral from s to infinity. It's nothing but f of t divided by t format. So the given problem, the stage when it comes while solving this differential equation, inverse finding stage, when we are reaching, these are all to be noted, and which is suitable to our given problem, we have to pick and we have to solve. Suppose this is not suitable, then so the convolution theorem. This conversion, the two functions will be there, that is f of t and g of t. The t is replaced by u, and here the t is replaced by t minus u. And we will do the integration with respect to u and the range from 0 to t. This is also a one trial. So using convolution formula, and we can solve that inverse Laplace. In case this is also not suitable, then Finally, we can go partial fractions method. The partial fractions method, very simple way. Suppose s square minus 3s plus 8 divided by s minus 2 s square plus suppose 9 is there. This we know it if s minus 2 equal to 0, which gives s equal to 2, it's a real number. Whereas coming to here, s square equal to minus 9, s equal to square root of minus 9, square root of the minus 1. That is negative number square root, it's nothing but we will be getting complex. So this can be solved. For the real a by this term we will write. For the complex b into s plus c divided by this we will be writing. So this is the way also we can proceed. So now we will be focusing on this our given problem, how to solve. So far we discussed how to work this given problem, the steps. When the stage the given problem the reaches inverse, these are the formulas which is suitable that we will apply. Yeah. Now solve the initial value problem by using Laplace transform method. So this is the equation which is given. So very careful at x equal to 0, y equal to 0. When x equal to 0, the first derivative of y, the value is minus 1. The step we are going to follow, that is, this is the given equation. The presentations we are writing, the given equation which is written, and we are going to take both the sides, left, right. Both the sides we are going to take Laplace transform. So Laplace transform, the operator is capital N. So we will be getting, applying L of L of. But whereas when we are looking the left side, L of 1, 2, 3 terms are there. But L of 3 terms at a time, we don't have Laplace formula. But the property which we have, linearity property using, we can split and we can write. So according to that, L of the first one is y double dash plus 7, L of y dash plus 10, L of 1. Equal to, here the 4 is constant. So 4 into L of e power minus 3t. Fine. So how we have written separate. That is using the linearity property. That is L inverse of two functions are there. L inverse of first function plus L inverse of second function. So now, this here the formula y double dash it is there. So the derivative, the theorem of Laplace, if it is y double dash, it's a small technique how to remember the formula. The small technique is, if y double dash it is there, we will start with s square L of y. That is our total, the equation in terms of y it is there. That's what we have taken L of y. If it is a f, we will write L of f, or if it is x, we will be writing L of x. So s square L of y minus s. So if you are noticing, s is going on decreasing order. Here s square, s power 1, s power 0. S power 0 is 1. That's what it is not written. And y of 0, y dash of 0. That is, if it is our question is 2 times derivative, then we will stop up to 1 time. We can cross check it. These are the ideas. to avoid the careless mistakes. The next one is plus 7. It is written here as it is. Now, here y dash it is there. So now, the first derivative, that is the reason we are going to start with the s, L of y. We know it, this is s power 1, s is going on decreasing. Then next is s power 0, that is the reason it is treated, we know it 1, it is not written here. Y of 0, fine. This 10 L of y is written as it is, and the right side just we have written same way have written here. So the last step, once again, it is we have put it here. Now, in this place, y of 0, it has become 0 because according to the problem condition. Whereas y dash of 0, it has given minus 1. This is also 0. So now, s square L of y, this is there. That place we are putting plus 1. Plus 7 s L of y. It has become 0 according to our problem condition. Plus 10 L of y equal to 4 L of e power minus 3t. In this, L of y, L of y, L of y, where it is common, we grouped it. That's what this step. That is L of y, s square, 7, s, this 10. Here, the plus 1 is there, that should be written. This plus 1 minus, this value is y dash of 0, the value is minus 1. So minus into minus, it has become plus 1. That only, this plus 1. And here, in Laplace transform, L of e power minus at. Simple way we can remember 1 by s plus a. Just the opposite will play a role. So while doing to remember the formulas, these are the simple technique way also we can remember. So now completely this is the one, and plus 1 we push it to right hand side. Then it has become minus 1. Now this to be right hand side to be solved. So the right hand side 4 by s plus 3 minus this s plus 3. So we are taking common LCM. So it is becoming 4 minus s minus 3. It's nothing but, so 1 minus s. So it is written here 1 minus s by s plus 3. So the next step, what this term, we push it to here. Now we have to solve. That is, this term, what we studied in lower classes, the factorization method, that is, s square plus 7s plus 10, it is there. Two numbers we will select. The two numbers, if you multiply, we will get 10 plus 10. If we add, we should get plus 7. They are plus 5 and plus 2. That's what plus 2 plus 5 it is written. It is a factorization method. Now, this to be solved. So the y equal to, the L we are transforming towards right. So the Laplace transform, it has become now inverse Laplace operator. Now the starting of the slide, we discussed that is the inverse Laplace transform. So many methods which is suitable for this. A fraction of a second in front of our eyesight it should go on. It is suitable our partial fraction. So according to So according to our partial fraction, so now s plus 3 equal to 0, s equal to minus 3. S plus 2 equal to 0, s equal to minus 2. S plus 5 equal to 0, s equal to minus 5. All are real numbers. So a by b by c by. If it continues, we will be writing d, e we will be taking. So we have taken the LCM. So the LCM we have got it a of s plus 3 into s plus 5 plus b of s plus 2 into s plus 5 plus c of s plus 2 into s plus 3. Put s equal to minus 2. This particular thing to solve, any way we can adopt. It's not a particular thing. What here is teaching, that only should be done. No, we can adopt any way to solve this equation to find the constant values, that is a, b and c. So now we are putting s equal to minus 2. Our main idea is, if you put minus 2 here, this 2 will be cancelled. The leftover, the variable, it is easy on its own way, it will be coming out the a variable result. So now here we are substituting minus 2. So it has become 3. This place a of minus 2 plus 3 minus 2 plus 5. So it is 1 and 3. We got it. So 3 equal to 3a, nothing but a equal to 1. So 1 we got it. The next one, put s equal to minus 3. So this and this will be cancelled, which leads to get the value of the constant b. So we will put it 1 plus 3. So minus of minus 3, it has become plus 3 b of. So putting minus 3 plus 2 minus 1 minus this one. So we are getting here. So now 4 minus 2b, it's nothing but b equal to minus 2. So the final one, s equal to minus 5. So the minus 5, if we put this and this, both are getting cancelled. So if we substitute in this particular place, we are getting 6 equal to here c of, so minus 3, here minus 2. So we are getting here, that is also 6 equal to 6c. It's nothing but c equal to 1. All the values we got it. That is a equal to 1, b equal to minus 2, c equal to 1. That we are going to substitute in the correct the places. That is, this is the equation. We split it in such a way according to the rule of partial fractions. What we obtained, a is 1, b is minus 2, c is 1. Those particular places we are going to apply the values. So we applied it. A has taken 1, b has taken the value minus 2. In the place of c, we substituted plus 1. Now, our question is y equal to L inverse of. So now, both the sides we will apply L inverse. So when we are applying this left side, it has become our equation, whereas the right side, L inverse of 3 terms are there. We know it. L inverse of 3 terms. So split L inverse of first term, L inverse of second term, L inverse of third term. How it is possible? It is possible only with the help of linearity property. So using the linearity property, so we split it and we wrote it. Now this is simple. The starting of your thing, we discussed a big list towards inverse Laplace transform, that is elementary function, first, second, change of scale, multiplication, division, derivatives, integrals, convolution, partial. It's a big list it is there for the inverse. But here what we got it, our given problem, simple elementary function. So it is L inverse of 1 by s plus 2. That is L inverse of 1 by s plus a. It's nothing but e power minus at. Our a place, it is only 2 is there. So e power minus 2t, this minus we kept it, this 2 has come out. So here L inverse of 1 by s plus 3. So L inverse of 1 by s plus 3, it's nothing but e power minus 3t. This is e power minus 5t. So we completed the problem, the application of Laplace transform. So we will come to a conclusion of this topic, problems on application of Laplace transform. For that, this is the question we have taken. So first, the working rule, the given question, Laplace will be taken on both sides. We will apply this initial conditions, then which will come as a format y equal to, in terms of inverse it will be written. So when we are writing in terms of inverse, which is suitable among these methods, we will apply. And our particular problem, we selected partial fractions method. And finally, we achieved the result e power minus 2t minus 2 e power minus 3t plus e power minus 5t. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.